Mrs. Pickett here, and this is our first official appetizer. I know that sounds strange because this is Algebra 1 and we're in math class, but I really want you to enjoy math this year, and so what we're going to do is I want you to kind of think about math class like you're going out to dinner every day. So an appetizer, that's usually the first thing that you eat when you go out to a restaurant. You get like a little snack before the entree comes, and so that's kind of what we're gonna do with notes. So notes are gonna be your appetizer. All right, it's gonna be me giving you the notes. I'm gonna record it here in just a minute. And then you will go home at night and you will watch the video. They're anywhere from like 10 to 15 minutes, so not super long. And you will take notes on your own outside of class. This way you can pause the video anytime you want. You can work as fast or as slowly as it suits you. Hopefully that will make you able to understand the curriculum a little bit better. All right, so we're going to jump in today and start. And I'm going to switch over here so you won't see me all the time on camera. And I'm going to pull up the notes. Now you have the option on Canvas. You can print out a copy of the note page. It'll look exactly like what I'm going to use. Or you can just use your notebook and just copy down what I do. So you'll put lesson 1-1, put today's date, and then start copying notes. All right, so give me a second. We're going to switch over here. All right. Everyone should be able to see the good notes page here, the real number system, and this is lesson 1-1. So as I start filling stuff in, I'm going to ask that you do the same, all right? So whether you have this page or you're in your notebook, let's go ahead and write down lesson 1-1 so we know what lesson this is for. And pardon my handwriting, it's not the best on here, but it will get better, I promise. Okay, so we are going to classify numbers and how to put them into different groups or sets, okay? And for our purposes, we're going to work with the real number system. Now, there are imaginary numbers, but we won't get into that so much this year. So, real numbers, we're going to start, and we signify real numbers by a capital R, okay? So, real numbers R. And this, for our purposes, this is all the numbers that we work with, okay? So, every number that we talk about is, in fact, a real number. Now, within that, they break down into two subcategories. You have irrational numbers and rational numbers. Irrational numbers, we're going to use a capital I. All right. Now, the most common one that people usually can point out is pi. Now, the reason pi is irrational, and you can see above there, it is a decimal that never ends, nor does it repeat. That means there's no pattern to it, like the same numbers don't keep coming up over and over. So a great example of an irrational number is pi, okay? Another one we could use would be the square root of 2. If you were to plug that into your calculator right now, you would get this decimal number, and there's no repeating decimals, there's no numbers that are the same, and it never ends, okay? It doesn't come out to be like 0.25. You can also have negatives, so we could do the negative square root of 101. Again, just another example, if you plug that into your calculator, you would see that the decimal does not end or repeat. Okay, so that's an idea of irrational numbers. It's when you have a decimal that does not end and never repeats or has the same pattern. Now, rational numbers, this is what you're more familiar with. We use the capital letter Q. All right, we've already used R for real numbers. So rational numbers are signified by a Q. And then rational numbers, it's something as simple as the number 2, okay? That is a decimal number. It ends. If you wrote it as a decimal, you'd say 2.0. We just shorten it to 2, okay? You can have fractions, so we could say the number 1/3. When you divide out 1/3, you actually get the decimal 0.3 repeating. So it looks like 0.3333333 and forever. It has a pattern, okay? You could also, we can have negatives. So we could say like negative 0.25, okay? That's a decimal number. It ends. Negative 0.25. It's like 25 cents or 1/4. That is a real number. And then since I use some square roots on the irrational, we also have square roots that are rational. If I said the square root of 16, and hopefully you know that's a perfect square, but the answer for a square root of 16 is 4. So that, again, is an ending decimal. It's a whole number, so that would be rational, okay? Now, within rationals, we can break that up into 3 other little subcategories coming off of rational numbers. So you have integers. That's everyone's favorite. That's your positive and negative numbers and 0. Okay, integers, we use the letter Z because we already used an I for irrational. So integers are Z. And then these can go in either direction, but I just want to show you. So you have -2, -1, 0, 1, 2. Then I'm going to put some little dots out here just to let you know, and I'll do it on both sides, that it continues in either direction. So -304, that's an integer. Or positive 2059, still an integer. All right, you can continue on in both directions. Whole numbers are different from integers in that they only include 0 and the positive numbers. So you can no longer use negatives. Whole numbers, we're going to use the W. All right. And then whole numbers would start with 0 and then anything increasing 1, 2, 3, and so on. And I'm going to put some dots here to let you know that that continues on indefinitely. And then the last one are natural numbers, and this gets even a little bit smaller because these are like your counting numbers. So when you're little and you start to learn to count, they usually have you start with 1. So natural numbers are different from whole numbers in that they do not include 0. We use a capital N, and then it would be 1, 2, 3, 4, and so on, as you wanted to go. Excuse me. So this, in a nutshell, is all of your sets of numbers. And so for our the rest of our notes today, I want to make sure that you can look at a number and decide what set it belongs to. So if you look at the bottom of the sheet here, I've given you some examples, some numbers, and you have to just tell me where these numbers fall, like what set. Is it a rational? Is it irrational? Integer? And so on. We're going to do a few together. So let's just start with 30, okay? Now, obviously, I told you real numbers. These are all the numbers we're working with. So the first thing I'm going to do is I'm going to put an R in the box because 30 is a real number, okay? Now I have to decide, is it irrational or rational? So does it end or does it never end? Well, 30 ends. It'd be 30.0 if you wanted to be technical, or just 30. So that's going to give me that it's a Q. It's part of the rational number set. Then I can continue on. 30 is also an integer. It is a positive number, okay? So I'm going to put Z. And then it's also a whole number, okay? So that's going to be a W. And because it's 30 and it's in the natural numbers, it's a counting number, it is also a natural number. So 30 actually fits into all of these sets. Let's jump down and look at number 7. So we have 6 over 3. So we have a fraction in this one. You're thinking, man, this is a different number. Be careful. When you are working with numbers, you should always make sure that they are simplified. So that way that you can decide what set they go in their most simplified form. Because 6 over 3, we know that that's just equal to 2. So even though this one looks different than number 1 where we just had 30, it's actually ended up going to be the same thing. Because we know that 6 over 3, which is equal to 2, would be a real number. It would be rational, that is an integer, it is a whole number, and it is a natural number. So it would fit into all of those sets, okay? Let's jump across to number 8, that's pi. I already kind of talked about it a little bit. So we know that pi is a special number, all right? It is, in fact, a real number, and it is irrational because pi never ends. Even though people try to figure out all the time, they keep going farther and farther and find more places, they cannot find an ending point or a repeating pattern in the number pi. If we jump down to number 11, we have -2.875. So obviously we know it's real. And then this one, it is a decimal, but it ends 0.875, excuse me. And so that's going to make it rational. And then from there, integers, whole numbers, natural numbers, remember those are all whole numbers. There can be no decimals. So there's really nothing else we can say about number 11. -2.875 is a real number and it is a rational number, and then that's it. It doesn't really fit into any of the other subsets. If we jump up and look at number 6, now I have negative, or the opposite of the square root of 9. Hopefully you know that the square root of 9 is 3. So this would simplify out to be -3, or the opposite of 3, however you want to call that. And so we're going to start. This one would be a real number. It would also be rational. And then this one we could go one step further. -3 actually fits into the integer category. Okay, so that would be z. Now we can't go any further because whole numbers and natural numbers have to be positive and this one's not, so we would be done there. So what I would like you to do then is, I've done a few of these examples. I want you to pick a couple, so 2 or 3, one, 2 or 3, probably 2. I would say at least 2, 3 at the max. Pick 3 of these numbers or 2, and you're going to go out to Flipgrid, and I want you to make just a little 90-second video for me, so kind of like I did for you. And I want you to tell me what sets of numbers they would belong. So you're going to pick 2 of these examples, and then just send me a short video back so I know that you watched the video and that you kind of understood what's going on. Now, if you're confused, don't worry. Bring all your questions with you to class tomorrow because we're going to continue this discussion in class, and I will be there to help answer any questions that you might have. All right? So thanks. I hope this worked out well, and I will see you in class tomorrow. All right? Have a great night, and we are all